Hello friends, welcome to engineering tutorial. So today we are going to uh, resume our discussion on network theory or circuit theory. So far in the previous topics which we have covered in circuit theory, we have covered various important concepts, but they were related to DC circuits, okay, direct current circuits. So the network theorems, the various concepts related to circuits and all of that. So if you see the previous videos, they were related to DC. So here we'll be starting a very important topic, which is alternating current or AC. So we'll be starting with the basic concepts and then we will go more and more into the intermediate and the advanced concepts. So first, alternating current AC, the basic concepts related to it. So suppose we have a signal waveform which looks something like this, okay, where this is the parameter, the signal which varies with respect to time, the y-axis, and this is the time axis. This, and we have the other which is like this. Like this, or something like this, or even something like this. Okay, so here let us add another where we have, this is the time, we have a signal like this. Okay, so what is the main difference between the signal waveforms which I have drawn in red and the ones which I have drawn in black? What is the main difference? So here you can see that for the red signal waveforms, here the value of the signal, it is remaining constant with time. It is a straight line parallel to the time axis. The value is remaining constant. It is not fluctuating. It is not changing. So the magnitude of the signal, the quantity, whatever it is expressing, which is varying with respect to time, that's why I have expressed it as a function of t. So it is remaining constant as time progresses. Okay, so here it is a positive quantity, okay, and here it is negative. Here it is negative, but it is remaining constant with respect to time. Okay, as time goes on and on and on, it also goes like this, constant. But the diagrams in black here you can see it is changing. First it is 0, it is starting with 0, starting from 0 here, here also it is 0, this one. Okay, so here it is starting from 0, then it is increasing, attaining a peak value here, then it decreases, then it goes in the opposite direction, attains a maximum negative value, then again goes to 0, and again the same pattern is repeated here. Here also same, it is starting from certain value, then 0 here, again in the opposite direction, then again the same pattern is repeated. Here again starting from 0, a peak value, then the downward slope, then again in the opposite direction, and then the pattern is repeated. So here you can see a certain pattern is being repeated over and over again in all of these waveforms. Okay, a pattern is repeated. Okay, a fixed pattern is repeated and the magnitude is changing continuously, and also it is going in both directions, in positive as well as negative. Okay, so these are the two important differences between these two signals. So the red signal here, the red waveform, they represent DC. Okay, DC waveforms, DC signal waveforms. And the black signals waveforms here, this one is sinusoidal, this is triangular waveform, this is square waveform. So these are AC signal waveforms. AC signal waveforms. So if we want to differentiate AC and DC supply in terms of two parameters, the two important parameters which separate the DC supply from the AC supply, there are two types of power supplies, the DC supply and the AC supply. We can differentiate them in terms of two important parameters. One is magnitude, one is direction. So in direct current or DC supply, whether it is voltage or current, whatever, the direction and magnitude of the current do not change. The parameter, whether it is voltage or current, here we are discussing direct current DC, so the direction and magnitude of the current, it does not change with time, it remains constant. Okay, and the voltage supply which provides direct current, it is called as the DC voltage. Same, the direction and magnitude of the voltage or EMF, it does not change, it remains constant with time. It can be positive, it can be negative, but it remains constant with time. This is an example of a DC circuit where we have a DC voltage source VDC connected to a resistor R that supplies a DC current as per the Ohm's law relationship. IDC is equal to VDC by R. So here you can see current is starting from the positive terminal. Here the positive terminal is upwards, the negative terminal is downwards, the polarity is plus minus. So current starts from the positive terminal, terminates on the negative terminal, like this. Okay, like this. Like this. So this is plus. The sign convention, if you please watch all the videos related to the basic concepts related to circuit theory and all the videos which I have posted first, and then come to this, because there I have discussed everything in detail. Okay, starting from the basics to the important concepts related to DC analysis of circuits. So current starts from positive terminal, terminates on the negative terminal, and this is the DC voltage and the DC current flows as per this relationship. So the waveforms, the DC voltage waveform, as we can see, this is plus, polarity is positive, so that's why it is in the positive y-axis, which is the voltage expressed as a function of time, and there is no fluctuation, no variation in the magnitude, so it is a constant. Okay, straight line parallel to the time axis, and the resultant current also same. Okay, it is not changing with time, same magnitude, and it is remaining constant with respect to time. Now suppose we suppose we change the situation. we draw the circuit something like this. Okay, minus plus, okay, and same resistor, this circuit. Okay, so here it is minus plus, the polarity is reversed, so here it becomes minus VDC. So you don't have to write minus VDC, already the polarity is already indicating that the direction of the current will be reversed. Okay, the direction of the current will be reversed. It will start from this positive terminal, okay, like this, and it will flow in this direction, and it will terminate like this. This is ITC. The direction of the current is reversed from this. Here it is flowing in this direction, so there will be voltage drop like this, plus minus. Here it is in the opposite direction, so the polarity will be like this. So the direction of the current is reversed. So in this case we express this as like this, okay, minus VDC, and also the current will be like this. So the minus sign, what it signifies is the opposite direction with respect to which the current is flowing with respect to this diagram. So plus minus, it signifies plus VDC, current is flowing in this direction, in clockwise direction, and in this case current is flowing in the opposite direction. Okay, so this is here VT, this is here IT. Everything is reversed, it is opposite, but this magnitude, even though it is negative, it is remaining constant with respect to time. Only the direction is reversed. Sorry. So this is the DC current, direct current, DC voltage and DC current. Next is alternating voltage and current. So it is just the opposite of DC. In alternating voltage, the voltage changes its polarity at fixed regular intervals of time. Okay, it changes its polarity. So it goes something like this. So first it will be in this way, then after a certain fixed interval of time it will become minus plus. Then again after a certain fixed interval of time it will become plus minus. Then again after a certain fixed interval of time it become minus plus. So the direction, the polarity of the voltage, it changes at regular intervals of time. So the two important parameters, magnitude and direction. Direction is changing, and also the magnitude of the current, it changes with respect to time. So both magnitude and direction, polarity, it changes with time. So the AC circuit, it looks something like this. Okay, so here you can see we have signified the AC voltage in the form of this, like this. Okay, this is the symbol of an AC supply. So it results in an alternating current. AC voltage results in AC current. So the signal waveform here, which we have taken for simpler analysis, is a simple sinusoidal waveform. This is the AC supply voltage waveform. So here you can see it starts from 0, attains a certain maximum value here, then goes to 0, and then attains the negative value here, and then again goes to 0. So it is expressed in this format in terms of the the mathematical expression. So here the voltage is expressed as a function of time Vt, which is equal to Vmax sine omega t. Okay, so Vt is called as the instantaneous value of the voltage. At any particular time instant t, what is the value of the voltage? Vmax is the maximum voltage, okay, the maximum voltage attained by the signal waveform. Omega is the angular frequency in radians per second and t is the time. So it is expressed in simple sinusoidal form. Why? There are very numerous advantages of expressing it in sinusoidal form. One of the most important is simpler mathematical analysis. So we'll go into that in detail in later videos. For now you just understand this is the mathematical relationship. Here in the second we have added an extra, this phi. It represents initial phase angle, but for now you consider it 0 because in this diagram there is no initial phase angle, it is starting from 0. So for now you just forget about this. This is called as the initial phase angle phi. This total omega t plus minus phi, it represents the phase angle. Phi is the initial phase angle, but here the initial phase angle is 0 because it is starting from 0. For just now you just focus on this mathematical relationship. It represents this Vmax sine omega t. So here what happens, let us try to understand this circuit. So what happens, let me copy it. Okay, so there are two parts to the analysis of the AC voltage which is driving the circuit. This part, this portion, from here to here, the positive peak, then to 0, it is called as the positive half cycle, the positive alternation. And here from 0 again to negative peak and then back to 0, that is called as the negative half cycle. Okay, so what happens is that during the positive half cycle, I'm talking, this one, the upper terminal, it becomes positive and this becomes negative. And the magnitude, it starts from 0, goes to the maximum value of the maximum positive value and then back to 0. Okay, but the polarity, it remains plus minus. So current flows from positive terminal to the negative terminal because that is the rule. Current starts from the positive terminal of the supply, terminates on the negative terminal. So current flows in this direction. This is the positive half cycle analysis. Then as a result of that, the resultant current waveform, it looks like this for the positive half cycle. This is for the positive half cycle. Okay, this is the current waveform. Okay, here it is equal to Imax sine omega t. Here also Ohm's law is dictated, where it is equal to Vt by R, Imax is equal to Vmax by R. So the current is also represented, the AC current, it is represented by the sinusoidal relationship. Imax is equal to sine omega t, where it is equal to Vt by R, Imax is equal to Vmax by R. Okay, simple Ohm's law relationship. Now this is the current for the positive half cycle. It starts from 0, attains a certain maximum value. So Imax is Vmax by R. Okay, Imax here is Vmax by R. So this is for the positive half cycle of the current. Okay, it starts from 0, attains a positive value and then goes to 0. This is for the voltage. Correspondingly, the current also, it starts from 0, attains a corresponding maximum value. So this is Imax here is Vmax by R, and then as the voltage decreases, the current also decreases as per this relationship. Okay, so this is for the positive half cycle. Then for the negative half cycle, what happens? This is for the positive half cycle. So in the negative half cycle, what happens? This upper terminal, it becomes negative, and the lower one, it becomes positive. So now the current flows in the opposite direction. So ignore this sign. Now the current flows in the opposite direction here. Okay, like this. So ignore this sign, you ignore. It is not valid for this case. So now the current flows in the opposite direction, because here the upper one is minus, lower one is plus. Current flows from positive to negative. Okay, positive to negative here. Okay, so here, starting from here and terminating here. With this. Okay, so for the negative half cycle of the voltage here, this is the resultant current waveform. So starting from 0, as the voltage goes towards the negative half cycle, so at the negative peak of the voltage, at the negative peak minus Vmax, we have the resultant current minus Imax. So here this negative current is equal to minus Vmax by R. Okay, so here for both the voltage and current relationship, this relationship is valid. Okay, with no initial phase angle. Okay, so this one is ignored here. The initial phase angle is 0. When we'll discuss phase of the AC, we'll discuss it in detail. So here Imax is the maximum value of current, It is the instantaneous value of current, omega is the angular frequency in radians per second, and T is the time instant. So this relationship is valid. So here I have expressed in detail this. So a sinusoidal signal waveform, it consists, AC waveform, it consists of two half cycles, positive half cycle, negative half cycle. During the positive half cycle, this is plus, this is minus, current flows in this direction. During the negative half cycle, the current flows in the opposite direction here. The lower one is plus, upper one is minus, and the current flows in the opposite direction. So here if you see, two important parameters which we discussed, magnitude and direction, both are changing. Because of this nature, starting from 0, increasing, then decreasing, magnitude is changing, and here where polarity is reversed, it is becoming minus, direction is also changing along with magnitude. So both magnitude and direction, it is changing for AC waveforms. So this is for the AC voltage waveforms, and this is for the AC current waveform. Another important thing is that we can draw the waveforms in two ways. In some diagrams you will find Vt with respect to t, where t is the time in seconds. Okay, and in some cases you will find omega t, where omega t represents the phase angle. So it is expressed either in radians or degrees. Okay, here the time, it is expressed in terms of seconds. Okay, here the phase angle, this is the phase angle with respect to phase angle, it is expressed in radians or degrees. So this is the two important difference. Okay, so you have to check whether the diagram is with respect to t or with respect to omega t. If it is t, then it is time expressed in seconds. If it is omega t, it is phase angle, which is expressed in radians or degrees. So these are some of the important basic concepts of alternating current. So in the upcoming videos, we'll be discussing more concepts related to it. Okay.